You said 2 and 4. Any others? All right, so let's go through those 3. The first one, you are given some equation. You're given domain values and you have to find the range, so y values. You could do this one of 2 ways. Put each of these in for x and figure out what your y is. Or put this into your calculator, put it, look at your table and find them that way. Either or does not matter. I'm gonna do it algebraically. If you did it in the calculator, that's fine. I'm gonna set each one of these up first. So if you were doing it by hand, you would put each of the x values in and then figure out what each of the y values would be. So this would be -6 plus 4 is -2. -4 plus 4 gives us 0. 0 plus 4 gives us 4. And then 6 plus 4 gives us 10. And then your final answer, you would just write least to greatest and curly brackets. Questions on that first one? The second one, you can use the vertical line test to see if each of these are a function or not. So if you draw a vertical line and it touches at more than one place, it is not a function. This one, no matter where you draw it, it doesn't do that. So this one is, same thing here. So this one is. So only the first one will not. Questions on that one? And then number 4, to find the x and y intercepts, we are gonna put 0 in for one thing, solve, and then put 0 in for the other thing. So if I put 0 in for x, I would just be left with my y term because this would become 0. And I would solve for y by dividing both sides. And we'll write that as a ordered pair here in a second, but then we could do the same thing for the opposite. Put 0 in for y. When you do that, the middle term would become 0, so you can write the 0 or leave it out, either or. And then divide both sides by 3. So then your intercepts would be at -4, 0. And 0, 2. Questions on that? If you haven't grabbed your calculator, go ahead and do that. And then if you haven't taken out your notes from not last class, but a couple of classes ago, take those out. If I remember correctly, we did this first one algebraically. We're gonna do 2 and 3, one in the graph, one in the one in the one on the graph, one in the table. And then any others we want to see, and then we're gonna switch gears. Anyone else need another one of those? Colton, do you have these? All right, so number 2, we're gonna do that one on the table, completely on the table, and then the last one we'll do completely on the or try to do mostly on the graph. So first, reset your calculator. Second plus 712. Reset it in second plus 712. Right, and then we're gonna put the second equation into our y equals. Once you have this in your y equals, you're gonna go into your table second graph. And then remember on your graph, you're looking for the y values that repeat. And you're looking for the middle of all those. So here, you may have to scroll up or scroll down. Where is the middle of all those? Where do your y values repeat? Where's the middle of all those? -1, 4. Remember, if you're not sure, let's say you choose 1, 8. If you see another 8 in your y values, that's not middle. So somewhere where your y value is not repeating. So -1, 4 is going to be the point we put in the middle of our table. And then you're just going to fill out the rest from your table. Going -2, -3, -4. Oh, just -2, -3. And then our y values were 5 and 8. Once you know half of your y values, you can repeat them. So this should be 5 and 8 again. Since we found this in the table, we know what our vertex is, with that point in the middle. Our axis of symmetry is the x value from that vertex. Our domain is the same as it was before, -infinity to infinity. And we'll talk about range in a second. So plot those 5 points. And it should look something like that. Then your range, we're looking lowest to highest. So what is the lowest y value here? Lowest y value. 4. And then that's our lowest. You don't have to draw the sign, but if that helps you see it, you can. Everything is above that. So our range, we would write it as y is greater than or equal to 4. Or we would start at 4, it's closed, and go to infinity. Remember that you won't be tested on domain and range for this unit, but it's good practice for when you are tested next unit. Questions on any of those things? Once you finish writing down everything, go ahead and put number 3 in your y equals. Here's x squared minus 8x minus 7. And this one we're going to do on the graph. You can go ahead and graph it. You can look and see where the middle of this would be, and it looks like it's going to be at -4, -1. But if I want to make sure, I can use my steps from the other day. Go into second trace. Because it was flipped upside down, that's going to be a maximum, so 4. And then pick some number to the left and some number to the right. I'm going to do -6. And 0. And then it has a bunch of zeros, but it's still -4, -1. So that would be our vertex. So that means our axis of symmetry is gonna be x equals -4. Our domain's not changing. And we know -4, -1 is gonna be in the middle of the table. So we can go forwards and backwards. And then really quickly on the graph, so on the same page, I can find my y values from here, or I can go to the table, either or. So go back into second trace. And if you look for a value, so if I go into 1 and I'm looking for when x is -5, it'll tell me what that y value is. So we'll pause there and then do the other one when we get back. Okay. I went second trace. You're looking for a value for the first one. And then we were looking for when x is -5, I just picked one of those, it doesn't matter which one you put in. Typed in -5 and hit enter. And it gave us that y was -2. So I can put that in my table. Then I can do the same thing for when x is -6. Second trace, the value. Oops, I hit enter instead of what I should have done. And then I can put in -6 and hit enter. And it'll tell me what my y value is. -5. And once I know those two, I can just repeat them. So this would be -2, -5. So then we can go ahead and plot all those points. So it should look something like this. For the range, what's our lowest point? -infinity. It keeps going down, so we don't really have a lowest point or don't know what it is. What's our highest point? -1. So then because this is below -1, it would be everything less than or equal to -1. Or we could say that it starts at -infinity and goes to -1. What questions do we have on any of that? On the next page, are there any you want to see algebraically in the graph on the table? I could say next few pages. If not, find the place that looks like this. So this is like a summary of all the graphing stuff that we talked about on this page. We're just gonna go through this. So the axis of symmetry is the line that cuts the graph in half. So if you want to draw in where that would be. That was not it's okay. On graph A, that would be this red line at -2. So we would write it x equals -2. What would the axis of symmetry be for B? What is the line that cuts that directly in half? At 3, that cuts it in half, so x equals 3 would be your axis of symmetry. Then we're looking for the vertex of both. Remember, that's your lowest or highest point on your axis of symmetry. So what would the vertex of graph A be? And then the vertex of graph B? And then if it's the lowest point, that's your minimum. If it's the highest point, that's your maximum. Is the vertex for graph A minimum or a maximum? Minimum. And then for graph B, minimum or maximum? Okay. Domain and range of both, we can put the domain for both because it's going to be the same. All real numbers from -infinity to infinity. And then your range for graph A. What's your lowest? What's your highest? What's your lowest y value here?
-5.
And then it keeps going up. So that would be everything greater than or equal to -5. Or we could write it as we're starting at -5 and it's going to infinity. For graph B, what's your lowest, what's your highest?
Four.
4 is the lowest or highest? Is 4 the lowest or the highest? Was that our minimum or maximum?
Oh, that's nice.
So that would be our highest. So it'd be everything below 4. So we could write it as y is less than or equal to 4. Or it would start at -infinity and go. Right, for this next part, they're asking which of these equations is for the graph. So we can eliminate a couple of them. For graph A, since this faces up, will the A value be positive or negative? You can look back in your notes if you don't remember. If this faces up, will the value be positive or negative? Positive. So anything that's negative for graph A, we can get rid of. We'll come back and choose which one in a second. For graph B, if it faces down, is your A value going to be positive or negative? Negative. So we can get rid of the positive ones. And then to figure out which one You could do axis of symmetry, you could put it into the calculator, graph it. I'm just gonna graph it. I'm gonna type in the first one. X squared minus 4x minus 1. And graph it. And on my calculator, this is going to the right. But on the graph, it's to the left. So it's not the one I chose, it's the one after that. And we could do the same thing for 8. If I put in C, negative x squared minus 6x minus 5. And graph that one. This one is over to the left, but on our paper, it's over to the right. That's the opposite. So hopefully you have a better summary of how to graph quadratics in standard form. We're going to briefly talk about how to do that in vertex form. Let's talk some questions. So the one Khan Academy that is on graph quadratic in vertex form will be based on this. So what's nice about when it's in vertex form is that there's less work for you to do because it really gives you the vertex if you know how to find it. So you're going to see this format, y equals some a value in parentheses x minus h, and then outside squared plus k. We're going to find our vertex by looking at the h and the k. That's like our x and our y in our order pair, but if we label them like that, then we'd have 2 x's and 2 y's, so they label it something else. When we look for the vertex, whatever number is on the outside is going to be exactly what it is. So if it says +3, when we write it in the order pairs, it's going to be +3. The x, however, is going to be different. So whatever is inside is going to be the opposite. So if this says x minus 2, it's really going to be +2. And we're going to talk more about like vertex form when we get into transformations. But I call this the rebel child. They don't want to do anything that you tell them to do. They always do the opposite. So every time you look at it, whatever it says, do the opposite. So our vertex would be +2, 3. So if you know what you're looking for, you can find your vertex and find everything else. The goal here is really just to find the vertex, not really to do anything else. So after we find the vertices of all of these, if we want to go back and graph it, we'll do that. Questions on this before we try the other 2? A good way to check yourself is if you put this in the calculator, you should see that that is your vertex. Either on the graph, in the table, any of those. So then what would the vertex of number 2 be? So as long as you look at that inside, you change it first and then put whatever's on the outside, bring that down. Questions on that? And then the vertex of number 3. So whatever it says, do the opposite. Okay. Of those, are there any that we want to see graph, in the graph in the table? And two. And then what method? Okay. So we can fill out some of this table because we know the vertex already. And we can go forwards and backwards. We want to fill out the rest of the stuff, we can also do that. But we would put this in to y equals on your calculator. Exactly as you see it, so 2 and then the parentheses, x plus 3 squared minus 1. And then go to the table, second graph. And then we can see what our values are. 1, 7. Then it repeats. So we can graph all of those points. -5, 7. -4, 1. -3, -1, and then it repeats. So look, something like that. And then our range, what's our lowest point, what's our highest point? -1 is the highest and lowest. Lowest, and then it's above that. So y is greater than or equal to -1. Or it starts at -1 and goes to infinity. If you're writing both, you don't have to write both. You can pick whichever one you like better, but it is good practice to do both. Okay. Questions on how we find the vertex in vertex form or graph it? Then we're gonna do one last thing. One last topic, 3 more problems, and we'll be done. So really, this sheet, the vertex form sheet, should have been with your other set of ones that you took notes. So the next set of notes I passed you is your lesson 3, the start of lesson 3. I want you to write down this definition first. So what it doesn't say is the word roots, but with quadratic equations, the roots is really what we're looking for, and they're also called these things, zero solutions and concepts. We've talked about that before. Once you have the definition written down, go ahead and draw these as well. Doesn't have to be perfect.
Really?
So this kind of goes back to when we were solving our quadratic equations using the square roots. And we got 3 different types of solutions, 2, 1, or none, same thing. So the goal with this will be, can you identify how many solutions you have and what they are? So these notes will be more than you'll have to do because they'll already be graphed for you, but the graphing part is good practice. Anyone still writing?
I should have.
Okay, so we're gonna do 3 problems, 1 algebraically, 1 in the table, 1 in the graph, and find the solutions. So let's do number 1 algebraically. So that's going back to what we were doing when we first started this. Finding our axis of symmetry. And remember that you'll have the choice of which you want to use or do. So this would give us -4 over 2 times 1. Which would just be -4 over 2. Which would just be -2. Then we'll have to find our y value, put that -2 in for all your x's. Be careful with your negatives, use parentheses. You can put that all in your calculator all at once. You can do it in pieces. How you do that is up to you. I'm gonna do it in pieces. If you put it all in your calculator together, that's fine. So this should give us -4 minus 5 is -9. Then we would have our vertex, -2, -9, and we can put that in the middle. There's more slots in this table, but it still goes directly in the middle. You can fill out your x's, go backwards and forwards. And even though we did the first part algebraically, you can do the second part, finding the rest of these y values algebraically, but I wouldn't suggest that. It would be time consuming. Use your graph or table. So So I would like the table more than anything, so I'm just find those values from here, starting from -5. So 0, -5, -8 would be the things I filled in. And then I would repeat those. Then we can graph all of those points. So it should look something like that. Before we find the solutions, how many solutions do we have? And your only choices are 2, 1, or none. 2. It crosses the x-axis twice, so 2. What are those 2? That's one of them. So we're gonna write them one of 2 ways. One, we can write them as x-intercepts in ordered pairs, -5, 0, 1, 0. Or we can write them how we were writing our solutions for the solving quadratics with square roots. X equals in curly brackets, least to greatest, -5, 1. Which you do for this doesn't matter unless it says specifically. The notation, set builder notation is this one. If it says write them as ordered pairs, you would do that first way. I will say that for our last lesson, we'll have to write them in the set notation. And that's good practice. Questions on that one? The next one we're gonna do in the table completely. You go ahead and put number 2 in your y equals. Did this incorrectly 2/3, so let me see if I can make up for it this time. Where is the middle? One. Where the x is 1 or the y is 1? So 1, 0 would be our middle. And that would be your vertex that you would put in the middle of your table. And then fill out the rest of your table. We have 1, 4, 9. And then it repeats. So we would take all those points and graph it. How many solutions does that one have? One. It only touches it once. Where? Or what is that solution? Where does this touch the x-axis? Like what number? Like what number? One. Yeah, one. So you can either write it as the ordered pair or write it as the set notation. What questions do we have so far? The last one we're gonna do on the graph. So once you have that written down, go ahead and put this into your y equals. And graph it. How many solutions does this have? One. It does not touch or cross the x-axis at all. The answer is none. You can put none in A. Doesn't exist. You cannot put 0 because that would mean there's an intercept at 0. Right, then we can graph it. So we answered it already, we just have to finish it, graph it. So I see that there's a point at 0, -3. And this point right here would be our vertex, 1, -2. I can fill in the rest of my x values. And then if you can see the points clearly on the graph, then you can fill in the rest. If not, you can do the second trace. Find the value when x is whatever. So I could do -2. Oh, wait, I know that one. I could do 1 and 2. So when x is 1, y is -2. I don't think that's what I need for it either. Yeah, I did that right. Okay. So if you were copying what I wrote down, you may need to fix it because I messed it up. Okay. I had to change all that. So I'm gonna do it again, but actually with the right value this time. So -1. Second trace value -1. X is -1, y is -6. And then I can do the same thing with -2 or 4. -11. Sometimes you'll get numbers on your table that won't fit on your graph. Do the points that will fit. Like this one is -11, this is 10 by 10, so I could probably graph that one. But if you get something like 15, 20, don't try to extend your graph, just leave that off. Look something like that. Do we have any questions on how we find solutions? So for the remainder of class, you have time to practice. I'm going to give you a few different options. The first set of notes, the graphing, you can keep practicing in those. If you haven't done Khan Academy from last week, you could use this time to get that done. You could start on Khan Academy for this week. The graph quadratics and vertex form you should be able to do. The other two, you may want to wait until next class. This page and this set of notes, once we do this, this will help you do those last two Khan Academies that are due this week. So you're welcome to look at it, look at the videos, the articles, and try it on your own, or you can wait till next class for that. If you want to practice in these notes, I would say to look for the last couple pages, starting here. This would be good practice. Okay, so use this time to practice. Let us know if you have questions, need help, anything like that. Yes, make a pass.